This video then looks at simultaneous equations, and because there are two techniques that we can use, the first technique can be used in certain circumstances, the second technique can be used in both, but it's a slightly longer process. We're going to look at them. So what is a simultaneous equation? Whereas two equations where they have two different variables in them, so they might both contain x and y, but those variables are the same value in the first equation and the second equation. For instance, I might have x plus y equals 1 in the first one and 2x equals 3 minus y in the second one, but I know that the x's are of the same value and the y's are the same value. And that when we've got a situation like this, we can actually work out the values of x and y using two different techniques. So you look at this, for instance, the first equation says that 2x plus 5 is equal to 5y and x is equal to y plus 2. Now, a lot of the time we don't know that the variables are the same. There might be two separate equations, but in this case and in the exam they'd say solve this using the simultaneous technique, or they might say the variables are of the same value, or might might have to apply it to a situation where and work out that it's insinuating that they're of the same value. So what is the first thing that we have to do? Well, if you look at the x by here, there's 1x. And what you need to do is look to see which of the variables down here is a factor of its variable above. So with the y, for instance, where this 1y, I could work with the y's because 1 is a factor of 5. If I multiplied 1 by 5, I would get 5. Down here, 1 is a factor of 2, so I can work with 2 because 1 times 2 is 2. I decided to work with the 2. It doesn't matter, you can do it either way, but I have worked with the x's. So what I've got to do is I've got to multiply the bottom equation by 2. Because if I multiply the bottom equation by 2, this x will become 2x, and then the number of x's in the top and the bottom will match, and that's what we want to have. So 2 times x will be on the left, and then whatever we do to the left, we've got to do to the right. So we're going to do 2 times y plus 2. So that's going to give me 2x. And remember, you're expanding a bracket. 2 times y plus 2. And notice how I put the y plus 2 in brackets because it's easier to see where you're going. The answer is 2y plus 4. A common mistake here, if I just jump back a slide, a common mistake is that without these brackets, students do 2 times y plus 2 and they end up with 2y plus 2. But if you put the equation in brackets first of all, remember, and from your expanding brackets techniques, that you are multiplying both the objects separated by the plus or minus in the brackets. So we end up with 2x is equal to 2y plus 4. So our first equation is still 2x plus 5 equals 5y. Our second equation is 2x equals 2y plus 4. And now the number of x's matches in the top one and the bottom one. So my next job is that because I have got the fact that 2x is equal to this value, and notice how the 2x is on its own. I haven't got 2x plus 3 or 2x minus y. I would have to move those over to the other side of the equation if they were there. I know that the value of 2x is 2y plus 4. So I can substitute this 2y for 2y plus 4. I can swap the 2x for 2y plus 4. So I've done that here. I've got the rest of the equation, plus 5 equals 5y, plus 5 equals 5y. But instead of writing the 2x from this top equation in, I have used the 2y plus 4. So I'm left with 2y plus 4 plus 5 equals 5y. And let's take away those brackets. And you notice now we've only got y's in this equation. And when you've got one variable in an equation, you can actually calculate it. So first of all, the 4 and the 5 will gather the like terms. Those two numbers can come together. So 2y plus 5 plus 4 becomes 2y plus 9, because 5 plus 4 is 9. Next, I want to move the y's. At the moment I got y's and a number over here, whereas I've only got y's over here. So if I move the y's over to this side, and it becomes 9 equals 5y minus 2y, I've got the y's over one side of the equation, the numbers over the other. 9y becomes 3y. Sorry, 9y is equal to 3y because 5y take away 2y is 3y. And if I got 3y and I only want 1, I divide it by 3 to cancel the 3 off in front of the y. And of course, if I divided the 3y by 3, I've got to divide the 9 by 3. Give me the answer, y is equal to 3. Remember, if this is going too quickly for it, have a look through solving and changing the subject videos and all the videos that we've done so far, because as we go further into algebra, the videos link up. And you will apply some of the older videos to this, or the information in the videos to this. Now I know that y is equal to 3, I can simply substitute it back into my old equation. I'll pick the easiest one, so I'll work with x equals y plus 2. I change the y to 3, and there's my answer. There's the x. X is equal to 5. So that's how we convert, work with two equations where we know the variables are the same value in order to work out the value of y and the value of x.